Hello, today I'm going to demonstrate an example of two different methods of AI used to create a guard character. The first method that I'm going to show you today is a finite state machine. Here is our level, and if we move down a bit, we can see our enemy. They're in their first state, the patrol state, where they're going to wander back and forth between the area of the map they've been assigned to patrol. If we are to throw a smoke bomb, say, and it detonates within the vicinity of it, they're going to go into an investigate state and move towards the source of the noise. Once they reach this source, they're going to search the area looking for the culprit. If we are to walk in front of the enemy sight line, they will enter the chase state and begin to follow us until we are out of their sight. We've escaped their sight line, and now they're going to begin searching for us using the last known sector we were in as a search location. They will remain in the state for roughly 10 seconds before resuming the patrol state until we cause something to make them investigate or chase us again. So whilst this method is effective in getting different types of behaviour and is relatively simple to implement, it is very rigid and can get repetitive very quickly, which isn't the best type of method for a game. We can expand this system to make it a lot more dynamic and a lot more interesting using fuzzy logic to determine different properties of the enemy that will make it a bit more dynamic in how it interacts with the world and the player. Alright, here's our enemy here, and as you'll notice, their speed is fluctuating between fast and slow, depending on how far away the target is. This is because fuzzy logic is controlling how fast they move based on the distance to the next target. The fuzzy logic version of the enemy has a unique set of conditions that allow the enemy to respond to the player's speed and how much noise they're making. The faster the player moves behind the enemy, the further away they'll be able to hear, and if they are heard, they will investigate the source of the noise. We've been spotted, so the enemy is going to chase us. There's two conditions at play here, the detection distance and the enemy's speed. As mentioned before, the further away we are, the faster the enemy will move, but the faster the player is moving, the further away the enemy will be able to detect us from, making it a lot harder for us to escape the view, making the enemy a much more interesting and engaging foe. Since we've been spotted a couple of times, the curiosity level is increased, which will make the enemy a lot better at hearing the player from further away. At a low curiosity level, the player will have to get really close even if they're moving fast, whereas at a high curiosity level, even going at a moderate speed will make them hearable from a good distance. So as you can see, we ran past the enemy at a fast speed and they heard us, so now they've begun chase. So they investigated us, and because we were spotted, they began chasing us. I will show that one more time before moving on to our final demonstration, which will show the two AIs competing against each other. I can tell which enemy is which based on the speeds. I can tell the fuzzy logic enemy is the one that is moving faster, as it has a condition that allows it to move faster depending on how far away the target is. Whereas the finite state machine version lacks this functionality, so it will remain at the static speed regardless of how far away it is. Let's get spotted by both of them and see how well they can chase us. That's both of them. Let's allow them a chance to catch up with us. As you can see, the fuzzy logic one is the one catching up, speeding up because we're further away, so it needs to go faster. And let's get them both to follow us down here and see which one keeps up better with us. As you can see, the finite state machine one has given up because it can't spot us, whereas the fuzzy logic one has kept up the chase as it was able to catch up with us and increase its detection distance, making it a much more challenging one compared to the finite state machine version of the enemy.